So basically I want to go through tonight the history of WA diamond exploration. I'm not going to talk in any detail of the Argyle mine, as Murray Rainey gave a great talk on this on Argyle last year. I'll talk a little bit about the discoveries in the Kimberley, the West Kimberley and the East Kimberley diamond occurrences. My motivation for giving this talk is that although a lot of older generations have heard the story many times, some of the younger generation probably have not. So just a bit about diamond geology. This is an ancient slide from my CRA exploration days. Diamonds are stable within what they call the diamond stability field, where temperatures and pressures are such that diamonds can form and are stable. Old cratons are most likely places for these conditions to be met, with the old coal lithosphere being preserved in deep cratonic roots. Kimberlites are volcanic rocks that form in and below the diamond stability field and rise up through the diamond-bearing layers, pick up diamonds on the way and transport them through to the surface as volcanic vents. You can also get lamprites formed in the areas marginal to the cratons, which can also pick up diamonds and carry them to the surface. Some of you might know this guy, Brian George, or Bruno. He used to run a small Gemco auger rig for us in CRA exploration days, and he went on to start his own drilling company in Leonora. You will also note that the amount of PPEs used at this time was not as prescriptive as today, but we got stuff done and most people survived. This auger rig was one of the prime follow-up tools for checking magnetic anomalies. The auger rig could be easily towed behind a Toyota and was highly mobile. Before the Ashton joint venture, or AJV, came into the Kimberleys in the late 1970s, Stockdale Prospering, a subsidiary of De Beers, and Stellar Minerals had carried out some preliminary diamond exploration in the region. This early exploration was based on research work carried out by Professor Rex Pryder at the UWA, where he indicated that there was a genetic link between lamprites in the Fitzroy Valley and microprudentites or kimberlites. Stockdale and Stellar did sampling down in the Nunkamba area and around the then known lamprites, including Mount Abbott, where they recovered pyrope garnet, but no diamonds. Diamonds had been recovered in the Leonard River at Fleet Camp Pool, just to the west of the Ellendale lamprite field. Resampling of the Leonard River in this area could not confirm the discovery of the diamonds, so the source of these diamonds is still a mystery. The photo on the right is of P Hill, just to the west of the old Nunkamba station. It is interesting that most of the outcropping lamprites were lucite-bearing lamprites, and these outcrops attracted the attention of many of the early explorers. In an interesting twist of fate, I did some work for the Transoil X-Men Consortium in 1974, and I later found out that they had the magnetic data over where the Ellendale lamps were now known. The pipes showed up as anomalies in the data, but no one did any field follow-up to check them out. But then again, no one was looking for diamonds in Australia at that time. The magnetic data was the old BMR, which was the precursor to Geoscientists Australia, and that was flown at 1 mile spacing. There was no detailed magnetics available in the region at that time. The early diamond exploration techniques in the Kimberley were based on the traditional African methods developed by De Beers over many years, comprising stream sampling where there was a well-developed drainage and loam sampling in areas of poor or no drainage. A number of people working in the early days of diamond exploration were ex-De Beers and brought these techniques to Australia. Geophysics was also used where available, looking for dipole anomalies usually on stack profiles. The African sampling methods were designed to look for pyrope garnet, picroilmenite, gram diopside and diamond. Rock and soil geochemistry would have been for nickel, cobalt, niobium and chrome. Cheap multi-element geochemistry was not available at that time. If you found a rock of interest that was potentially diamondiferous, then you need to take a bulk sample of say 10 to 100 tonnes, which was usually processed through a mobile dense media plant or a jig plant. The plants usually recover material down to about 0.8 millimetres. Macro diamonds were therefore classified as greater than 0.8 millimetres in size, usually recovered in a jig or a DMS plant, and microdiamonds were less than 0.5 metres in size and recovered in specialist laboratories. This slide illustrates some of the work we did in the West Kimberley with the Ashton joint venture. The top left is RAB drilling in the JK Yard lamprite, east of Fitzroy Crossing. The top right is excavating a lamproite dike near Mount Cedric to the west of Nunkambar. Lower left is Erdman Habig in a trench in the Mount Noreen lamproite with his dog Sam. I worked with Erdman for a couple of years and he was a great mentor, organised and meticulous. And I'm grateful to have worked with some of the great geologists of CRA Exploration Group like Frank Hughes, Doug Fishburn and Warren Atkinson. On the bottom right is a bulk sampling of the Mount Noreen lamproite. We recovered a 0.25 carat diamond from this sample. We were recovering diamonds from some of the lamproites, but nothing at that time approaching economic. Some of the recent comments I've heard from the younger geologists looking at the old diamond data and saying it is of poor quality. This I totally agree with. We recorded all our data on paper. There were no computers when we were doing this work. There was no GPS. For navigation, we had 1 to 100,000 K topographic maps and all black and white 1 to 80,000 scale aerial photographs. The Columbaroo joint venture was formed in the mid-1970s, and the history of how the WA diamond hunt developed is described in a recent book by Stuart Kells, Argyle, The Impossible Story of West Australian Diamonds. This is an interesting read, and it describes the background of how you and Tyler assembled and funded the Columbaroo joint venture and its morphing into the Ashton joint venture, the HAV, when CRA joined in 1976. You and Tyler had been a student of Rex Prider, and by his determination that the diamond hunt was started in the Kimberley, which led directly to the discovery of the Argyle mine. The Columbaroo joint venture did broad-space stream sampling across the Kimberley block looking for kimberlite indicator minerals. This was all done on a shoestring budget with samples being observed in a kitchen in West Perth. The result of this work was the discovery of kimberlite indicator minerals and diamonds. These discoveries were game-changing as no one had found diamonds and indicator minerals in this region previously. As time went on, they needed more funding to expand exploration, and so invited CRA to join the joint venture, and it then became the Ashton joint venture. The AJV also started looking at the lamproites in the West Kimberley. Some initial sampling of the Big Spring lamproites by Chris Smith and Dean Lee, I believe, near Leopold Downs, showed the presence of olivine lamproites and breccia, and sampling recovered chromite and small diamonds. This was very significant as it was the first known occurrence of diamonds in lamproite. However, De Beers already knew this as some of the lamproites in Zambia contained trace amounts of diamonds. The AJV then knew that chromite was a key indicator for lamproite. The initial search had been on the Kimberley Craton exploring for traditional kimberlites, but now with this new realisation that lamproites in the mobile zones marginal to the Kimberley Craton have the potential to be diamondiferous, this expanded the diamond exploration to other parts of the King Leopold and Halls Creek mobile zones. Exploration techniques for the AGV was now to continue with stream sampling in areas with well-developed drainage and fly regional broad-spaced aeromagnetic surveys at 250 or 300 metre spacing. This gave a significant advantage to the HAV as they could then quickly follow up any dipole magnetic anomalies seen in the data. As the data came in each day to the Derby shed, the geophysicists would roll out the profiles, yes, actually roll them on the floor, and pick the anomalies. These would then be transferred manually to the flight path plots and the locations sent to the field crews for follow-up. Field follow-up comprised a geointerferably locating an anomaly using a Sintrex MP2 magnetometer by running 2 or 3 lines across the geophysicist's picked location. Loam samples were collected from the centre of the anomalies and sent to Perth for indicator mineral recovery. Once the anomaly had been confirmed, we would bring in the auger rig or RAB rig to drill the target and collect samples for geochemistry, and if lamproite was confirmed, a 50 kilogram sample for microdiamond analysis. An attempt was made in the field to identify the lamproite type, as the olivine lamproites were the most diamondiferous and the lucite lamproites carried out only a trace or a barren of diamonds. Microprobe analyses were carried out on chromite grains, and compilation of this data allowed certain chromite compositions showed to be associated with diamonds. Bulk sampling was typically done on any lamproite, olivine lamproites discovered. If the cover was shallow, less than about 4 metres, the trench was dug to excavate the material for processing. During 1979, in areas of deeper cover, a Hughes auger was borrowed from the Allendale project, where it was being used for deep sampling of some of the Allendale pipes. You won't be able to read this, but it is an example of the way the data was presented in the pre-computer days. All the necessary data was compiled onto one or two plans. This example is from Menisbor number 1 lamprite in the Calwinata field. On the top left are the results of the ground MAIG survey, locations of any surface samples like loam samples, the mineral sand claim corners if applicable, and all coordinates are in local grid. We had no GPS in those days, so we had to tie the grid into something, often a mineral claim datum peg or an iron star picket. Ground MAIG surveys required the person operating the magnetometer, usually the geo, to write down on cards each reading at each station. We had another magnetometer back at the camp recording the diurnal variation for the day, and we could manually correct our field readings against the base magnetometer. The corrections and plottings was done at night onto graph paper. No fancy computer stuff in those days. The advantage of hand plotting and contouring the magnetic data was that you got a good feel for the data. Note the trend section on the top right above, and the drilling and geochemical data. Most grids had a 1000, 1000 or 10,000, 10,000 grid origin, and trying to locate this data today can be a challenge. The mineral claims in the Ellendale area were surveyed, so this allows for a pretty accurate location of the old data. Unfortunately, most of the work that was done in the West Kimberley, the claims were not surveyed, so sometimes it can be difficult to find the exact location of these grids. The discoveries by the Ashton joint venture in the Ellendale area created a big diamond pegging rush throughout the West Kimberley. Many junior companies flooded into the area and tried their luck to stake ground. Most found nothing, but a few of the more determined groups found lamprites. Most of these juniors focused on the known lucite lamprites, which were outcropping. Pegging at that time required the physical pegging of mineral claims with corner pegs, intermediate pegs along the claim boundaries. This kept many surveyors and field crews busy for months. The key was that the lucite lamprites outcropped, whereas the olivine-rich and potentially diamondiferous lamprites did not. This is an example of the contoured BMR 1 mile spaced magnetic data with the locations of most of the lamprites in the Ellendale field. In this presentation of data, you cannot see the pipes, but if you looked at the stack magnetic profiles, you would have seen the occasional blip that represented a pipe. The takeaway from this is that if you're using wide space data and looking for small features, always look at the individual line profiles. Gridding will smooth out the little spikes that are the pipes. The good thing about the lucite lamprites is they stuck out of the ground and really helped the interpretation of their internal geology. These two images are from the 81 mile vent, or Ellendale 5, and show bedded lamprite tuffs with dropstone in the right-hand side image. The centre of this vent was filled by micaceous lucite lamprite lava lake. The pyroclastic units are well exposed with low angle cross bedding, indicative of base surge eruption activity and impact sags, where clasts have been ballistically in place. I made a geological map of the Mount Abbott lamprite and did this on my son's Sundays off. What else was there to do? You camped in the middle of the bush. The area had been pegged on the ground for a MAIG survey, so I used this as a basis for my mapping. The large sandstone exposure forming the Mount Abbott itself is actually a sandy crater infill. I didn't notice this at the time, back in 1979, but a later visit by Volker Lorenz, a famous phreatomagmatic MAIG geologist from Germany, identified a crucian lapilli at the base of their sandstone cap, overlying the sandy tuffs of the vents. To capture some of the stories from the early exploration days, the ARG have begun the compilation of a series of war stories in the early days in the Kimberleys, leading up to the discovery of Argyle and Aries. Keep an eye out. We're hoping to have this publication done later in the year. If you have any great stories you'd like to share, please get in contact with me. There's still time to have them incorporated in the volume. Photos are always welcome as well. I'm only going to talk briefly about the Argyle discovery, as Murray Rayner has been through all the details on Argyle late last year. But for those who are not at Murray's talk, I'll give a quick overview of Argyle. Argyle was discovered in late '79 and 3 years after the Ellendale diamond discoveries. This was because the Horseshoe origin was initially considered a low priority area. Early sampling had been to the west of the Great Northern Highway, only 20 kilometres to the west of the Argyle mine. In fact, you can see the Argyle mine from the Great Northern Highway just north of the Bow River Bridge. This is a valuable lesson in that the best mine was found in an area of low priority, so always test your assumptions. During an investor's visit to Argyle in the early 1980s, I was asked, what are the odds of finding an Argyle? And I said they were so infinitesimally small, only a geologist would do it. The Argyle discovery was a result of regional stream sampling in a low priority off-craton location and good quality stream sampling, not to mention the commitment the AJB had to continue the diamond exploration search in the region. The Ellendale discoveries were not high enough grade to be economic at that time. Two samples collected in Smoke Creek by Maureen Muggeridge and John Tower in the mid-1979 contained diamonds. Recovering diamonds in a stream sample is rare, and having two samples in the same creek is very significant. Frank Hughes and Warren Atkinson flew into the area and followed the trail of diamonds up into the valley that contains the Argyle pipe. At that time, the pipe itself was half covered by a temporary reserve held by uranites as part of the uranium exploration work. The TR was nearing its expiry, and the AJB waited until it had expired before launching into their claim pegging operation. I was involved with the pegging, which comprised initially helicopter support and later followed up by ground-based pegging. All of the pipe and the associated alluvial deposits were claimed at the time, except for an area down the bottom end of Limestone Creek, which was later pegged by GM Exploration. TRA Limited in Melbourne announced the discovery partway through this pegging activity, and numerous address peggers swarmed into the area. This is a view of the valley that contained the Argyle pipe. So this is down near the southern end looking towards the north. There was nothing particularly special about this valley except that it contained one of the richest diamond deposits in the world. This is a higher view of the Argyle area. The pipe lies in the valley on the left of the photo. Smoke Creek drains to the north towards Lake Argyle in the distance on the upper right-hand side of this image. Limestone Creek flows out of the centre of the pipe, initially to the east and then to the northeast. The Normandy Poseidon Bow River mine was located on the lower reaches of Limestone Creek, near the Evelyn Range, in the top right-hand side of the image as well, just this side of Lake Argyle. The trenches in the foreground show the extent of the alluvial sampling for the Limestone Creek alluvial deposit. The Argyle pipe had a geochemical and mineralogical anomaly of over 350 square kilometres, with many diamonds found in many drainages around the Argyle area. The pipe is about 2 kilometres long and 300 to 400 metres wide, and mainly filled with quartzose olivine, lapilli, ash tuffs, termed sandy tuff in the mine. There are also phases of non-quartzose lapilli ash tuffs and small phlogopite olivine lamproite dikes of lower diamond grade. Sandy tuffs range in grade from about 1 carat per tonne to over 30 carats per tonne in localised areas in the southern part of the pipe. The pipe has been dated about 1178 million years and into mid-Proterozoic sediments in the Horse Creek mobile zone. This is a 3D view put together by Murray to give a bit of a show of what the Argyle deposit looks like at depth. There's a number of routes, like tooth routes running down underneath. You'll notice that that dip to the left is indicating that the diatreme has been tilted to the north in parallel with the local stratigraphy. The variety of rock types found at Argyle are fascinating, with many textures in the Argyle pipe seen in many other volcanic rocks around the world. The volcanic process is the same in these lamprites as were described principally in major volcanic rocks associated with ferromagnetic volcanism and marred diatreme formation. The AJV adopted traditional volcanological rock terms and contrasted with the typical approach of De Beers giving the rocks special rock names. This slide shows some of the typical rock textures and textures of the lamprites. The dark angular fragments are olivine lamprite clasts that have been chilled and shattered in ferromagnetic eruptions. and the grey matrix comprises very fine ash and quartz sand. So where are the diamonds? Well, this is on the right-hand side. It's an image of a diamond in thin section, so it's probably a bit thick when the section was cut. But it shows it's in the ashy matrix between the quartz grains, which are the big white grains in that slide, and they also occur within the olivine lamproite class as well. So the variety of rock collectors is fascinating. The large diameter drill core that we drilled during the evaluation period, this was 8-inch or 200 millimeters in diameter, and illustrated some beautiful bedding features in some areas of the sandy tuffs. Note that there's a small thin depositional fault displaced in the bedding on the right-hand 2/3 of this section of core. We also saw a vesicular clast, which contrasted with more typical chilled fine-grained blocky clast and indicated changing eruption conditions during the development of the Argyle pipe. Biamo-like clasts were also seen and showed soft sediment deformation within the volcanic pile. Great volcanological features adding to the story of the development of the Argyle geology. We also get water escape features. On the left is a sandy dike containing the occasional lapilli, cutting sandy tuffs. And on the right-hand side, the drill core showing wispy, fine-grained ash seemingly flowing up through the rocks. These water escape features are common in water-saturated, coarse-grained sandy rocks, and again adds to the Argyle story. Right up in the northern end of the pipe, there are exposed crater sediments with intercalated cliff siltstones and mudstones. We also saw a great example of dropstone as shown on the left of this slide, clearly indicating subaerial eruption conditions at the time. Okay, enough of the history. What's happening today? With the diamond discoveries in Canada in the early 1990s came a huge amount of data on kimberlite geology and indicator mineral chemistry. The aim of all this work was to improve the area selection techniques and be able to prioritise which indicator mineral trains to chase with the best chances of finding an economic mine. Canada was a completely different exploration environment as it was mostly glaciated terrain with sheets of till covering the landscape. There's also been an upsurge in diamond prices recently, which has also spurred some extra diamond exploration recently. Everyone has seen the Argyle diamonds, but the other diamond deposits in WA have also produced some great diamonds. This petri dish on the right-hand side is a small collection that we had at the Argyle alluvial plant to show visitors the early pre-pipe mining days. Note the triangular mackerels, elongated, octahedral and irregular forms. Ellendale was famous for its fancy yellow diamonds, and these yellow stones commanded a significant price premium. Burgundy Diamond Mines and India Bore Holdings are currently working in the Ellendale area trying to re-establish a mining operation. Aries is a kimberlite pipe on the Kimberley Craton, and although low grade, contains about 95% gem or near gem diamonds. Odessa Minerals hold the tenements over the Aries kimberlite cluster and are planning to do extra work on that kimberlite during the coming year. In 1986, WA hosted the 4th International Kimberlite Conference, where we showcased the kimberlites and lamproites of both Eastern Australia and the Kimberley of WA. Bulletin 132 of the WA Geological Survey was written prior to the conference and is a very good summation of the knowledge at that date. Since the publication of Bulletin 132, there has been a number of new kimberlite discoveries, and the available diamond exploration data was compiled by Mark Hutchinson in 2018 and is compiled in the GSWA Report 179. Note that in the 1970s and 1980s, a lot of exploration was done open range, which meant without tenement, and so was not reported in the Mines Department. Mark was able to get some of this open range data, so it's a great compendium of what's available. This slide shows the location of macrodiamonds and the yellow diamonds and a measure of the microdiamond density from regional sampling in the colour bar. It's clear that most of the diamonds have been found in the Kimberley area, which forms part of the North Australian Craton. The grey areas are essentially underexplored. Even though a large number of kimberlites and alpha matrix lamproites have been found across WA, most of the diamonds recovered are concentrated in the Kimberley, but this might be a function of the amount of work done in the other areas. There's also been a lot of work done recently on the lithosphere and mantle structure of Australia. Remember, for diamonds, we're looking for areas of old, cold, deep keels of cratons. And seismic tomography is one way to characterise these areas. Note that the data is only relevant for today and not as a lithosphere might have been a billion years ago. The left-hand side image illustrates the calculated shear wave speed of the mantle at depth, with the cooler colours indicating faster wave speeds and therefore cooler rock temperatures. The right-hand side diagram shows the interpreted lithosphere thickness. So we have a temperature at depth and the thickness of the lithosphere, which helps together to highlight areas that may be prospective for diamond exploration. This slide is from Hutchinson and it is a summary of the recovery of diamond indicator minerals and the prospectivity based on the previous slide. Areas of high prospectivity are the Kimberley, the Pilbara, and somewhat surprisingly the Eastern Goldfields. So for all of you gold and nickel explorers out there in the Eastern Goldfields, keep your eye out for dipole magnetic features or any strange rocks that you might drill. Jason Myers has been finding some previously unidentified impact structures in the goldfields, so there may be more kimberlites lurking in the data or drill core as well. Okay, so what diamond exploration is going on today? As far as I know, there are 3 active diamond explorers spending money on diamond exploration. Burgundy Diamond Mines has recently optioned to Gibb River diamonds tenements over a large part of the Allendale diamond field, including the Terrace 5 alluvials and the E4 and E9 pipes and dumps. Burgundy have a bulk sampling plant on its way to Australia at this moment and plan to carry out extensive bulk sampling of the Terrace 5 alluvials this year. Burgundy are seeking the high-value fancy yellow diamonds for which Allendale was famous. They've also set up their own cutting and polishing facility in Perth. They raised $50 million last year for the diamond exploration projects in Australia, Canada and Botswana. India Bore Holdings is a private company and they have tenements to the south of the Allendale 4 pipe, testing an old alluvial channel. They have recovered a number of diamonds and continuing their bulk sampling program this year. Lucapa Diamonds have a joint venture with Booking Diamonds project and have discovered at least one small diamondiferous lamprite near Leopold Downs and are continuing their work this year. Lucapa's main activity in Australia will be the redevelopment of the Merlin Diamond Mine in the Northern Territory. Odessa Minerals is a new diamond float and they have tenements over many of the historic West Kimberley lamprites as well as the Aries kimberlite. So there is a bit of diamond exploration activity and hopefully some exciting news will come out this year of a new discovery or development. If you find something strange, who are you going to call? Ask yourself, is the rock an intrusive volcanic rock or breccia pipe? Does the rock have anomalous geochemistry, high niobium or rare earth elements? Kimberlites and olivine-rich lamprites are rare rocks and weather rapidly in warm tropical climates. So near surface, they may be just clays, otherwise known as yellow ground. So if you find something interesting, call me. The next diamond mine may be found by accident, looking for gold or nickel, but hitting something else instead. Keep your eye out for dipole magnetic features that may represent intrusive pipes. Remember, Argyle was found in a low priority area of the Kimberley. Okay, thanks everybody for their attention and I'll ask for any questions.